Good evening, everyone. Good evening, friends. Welcome back to our sessions on NLP, Natural Language Processing. So, in the previous sessions, we have discussed classification, regression, and neural networks, right? So, in this particular session, we are going to understand how or what is NLP. Okay, what are the variants that we have under NLP? Okay, then now the pre-processing types, the steps that we generally implement. Okay, as part of NLP, we are going to understand all the pre-processing steps one by one. So, friends, if you are aware of NLP, so this will be like a revision session. And if you are not aware of NLP concept, which is widely used, okay, so this will be a wonderful session for you to start your journey, right? So, how many of you have used ChatGPT? Did you use ChatGPT? No? Seriously? Yes. All of us might have used ChatGPT. If not, are you using any, browsers, search engines like Google search? Okay. We have Microsoft Edge. There are n number of search engines, right? So out of all the search engines, have you never used any of the search engine in your life history? Obviously, all of us, whenever you want to learn a new topic or if you want to browse anything, okay, so obviously we'll go and use a search engine. Then haven't you ever used Alexa, Siri, voice assistants like bots, chatbots? Again, all of us, right? See, why am I using all these, why am I bringing all these in our discussion is ChatGPT, any of the search engine, even the bots use NLP as one of the fundamental, topic. So without noticing, we have used NLP so far, right? So today we are going to understand how this NLP works and what exactly this NLP is, okay, and what are the variants we have under the NLP, okay, and the pre-processing steps, right? We also will also come up with some use cases by the end of each and every topic, right? So without no further delay, let us start our session. So our agenda, you see, we have our agenda described clearly. We'll get introduced to NLP first, okay? Then once after getting introduced to NLP, we'll understand what makes the difference between text mining and NLP. There are two different variants. One is text mining and another one is NLP. So we'll understand the difference. Then now we'll start with the pre-processing steps one by one. Okay, so what are the pre-processing steps that we discussed on structured data will be completely different on unstructured data. Why? Because what is your primary component of data here? Text. NLP works on text data, data related to text. So what kind of data is text, friends? Is it structured, unstructured, or semi-structured? I want everyone to answer. What kind of data is text? It is unstructured. Good. Unstructured data. So the pre-processing steps, whatever we have discussed on structured data, we are not going to follow the same. on unstructured data as well. So the pre-processing steps will vary. We'll start understanding the pre-processing, the cleaning steps. Okay. So out of the pre-processing step that we'll be discussing, we'll start with lower casing. Okay. Then spelling correction, tokenization, the types that we have in tokenization. Okay. And parts of speech tagging. POS tagging is something mandatory. So we'll also cover POS tagging, then stop word removal. Whatever the stop words that we'll have in the text, we are going to remove the stop words. Okay. Then we have stemming, lemmatization. Okay. So what is stemming? What are the types of stemming we have? Then lemmatization we'll also discuss. Okay. Then word sense disambiguation. Okay, so we'll discuss what is this word sense disambiguation, and bag of words comes into the picture. Okay, then finally n-grams, TF-IDF. Okay, so term frequency, inverse document frequency, how it is calculated, what is the formula, we'll understand, and finally we'll visualize text. So all these steps we'll understand one by one, steady and slow, right? So let us understand what exactly is NLP, natural language processing. So you see, it is a subfield of AI. It is it is a subset of AI, artificial intelligence. Okay, so in the forenoon session, I have discussed neural networks, deep learning concept, right? So even NLP is a subset of AI and computational linguistics, isn't it? Yes. So what is the purpose of using NLP? It focuses on enabling machines. So whatever the machines that we use, especially computers, okay, it enables computers to understand, interpret, and generate human language. So like how we are able to communicate. In the same way, whatever we communicate with a machine, probably a computer, so it is going to help a computer to understand, then interpret whatever it understands, and finally generate a similar kind of language like us. Okay, and that would be meaningful and useful, right? So this is the task of NLP, natural language processing. And NLP combines computer science, linguistics, and ML to bridge the gap between human communication and computer understanding. So, between human and a computer. Okay, so the gap between a human and a computer will be filled by NLP, right? And here are the primary goal. So in order to have a seamless interaction between humans and machines, we use a natural language processing, that is NLP. Okay, so using a natural language, there should be some continuous interactions, right? Like how we use ChatGPT, we give prompts, and immediately it understands the prompt, and based on the prompt that we give, it is going to give us the output, right? So in the same way, it aims us to understand, then generate. Okay, even now it translate the languages. So we also have some Google translators. Okay, Google Translate is available. Not only Google Translate, we also have some other applications where we can translate the languages, and it is also helping us to analyze the text for getting insights, right? So these are the primary goals of using NLP. I hope we had a clear picture regarding NLP. So let us move a bit to understand the history of NLP. When did it start? How did it evolve? Okay, now in today's generation, what is the role of NLP? We'll understand. You see, So this is not a new topic that started 20 or 30 days back. It's been almost 70 years that NLP has started. Early days around 1950. Okay, so there are some kind of research happening that time, and it relatedly there is a good amount of work done, and we were able to develop neural networks. So under neural networks, there is a type of neural network called RNN. Okay, so this RNN helps us to work on sequential data, text data. Okay, so in 1980s, RNN has been evolved, and there is a good amount of work done, and immediately we have models generated for speech recognition in 1989, and in 1997 we have LSTM, which is an enhanced RNN model. Okay, so the main objective of RNN is to work on sequential data. Recurrent neural networks work on sequential data. So what is meant by sequential data? The best example that I would tell is text, time series data. So when you take time series data, how would the data would like be? The data would be like, you know, in a sequence. What is the profit that we got yesterday, then day before yesterday, then so on. So in a sequence, you'll have the data. That kind of data is called sequential data. Even text is an example of sequential data, one by one, right? Then next to sequential data, I mean next to RNNs, there is a type of RNN, okay, that is LSTM, okay, which is actually enhanced RNN models has been introduced. Even the results are good when we used LSTM model. And in the early 2000s, between 2018, okay, so deep learning has, and the rise of neural networks has been increased, and we were able to use pre-trained models like Word2Vec, okay, then GPTs, BERT, okay. So all the companies started doing research in the space of neural networks, and everyone have came with their own network, right? So GPT, BERT, okay, BARD. So there are n number of models, networks have been raised in this plan. Immediately in the current market today, if you see, we were able to learn, we were able to use LLMs. We were able to use LLMs. Chat GPT is an LLM. Okay, so day by day, as the research is still going on, the models are also being developed with good amount of efficiency. The output is very high, okay, and you know one of the widely used LLM that we are using in the current market is ChatGPT. Yes, okay. Even we have Google Gemini, then Microsoft Copilot. All of these are different LLMs from different organizations. Okay, we have a LLM from Meta. Okay, then Amazon. Yes, each and every top company organization have come up with their own GPT LLM. I hope it's making sense. So this is the history of NLP, from where it has started, and today what is the role of NLP in the market. I hope it's making sense. So friends, if you observe in the real time, okay, if you take or if you consider the entire data as 100%, assume in the entire globe, okay, on the entire globe, if you say that the data that is being, if you measure what is the percent of data that is present on the globe, I'll say it as 100%. Out of this 100%, you know only 20% of the data is structured. Only 20% of the data is structured data, which is formed in the, which is in the form of tables, rows and columns, plus we'll also have the schema. But what about rest of the 80%? 80% is in the form of unstructured. 80% is in the form of unstructured. So as we have more amount of data, more percentage of data present in unstructured format, there is a lot of research happening in this space of text, textual data, image data. Okay, so image, and I'll also keep videos here, because videos are nothing but frames that we can, when we combine all the frames, you'll get a video. So frames are nothing but images, right? So text data, speech, then audio. Okay, so all these fall under unstructured data, and NLP will be used in the space of text and speech, right? So more amount of data, so that is the reason there is lot of research happening. And slowly, if you see the progress, how the models have been raised. Okay, and today we are in the space of using LLMs. So probably in tomorrow, uh, next coming 2 3 4 years, we'll also use something else, right? Something else will be invented, and we'll be start using them. So friends, do learn the concept of NLP, because this is one of the primary skill that is being expected if you want to be an AI engineer. If you want to be an AI engineer, for sure you have to be good at NLP basics, natural language processing. So this is one of the primary skill that interviews are looking at, uh, the resumes. Okay, right? Because NLP is part of AI, right? So one of the key component. Now, if you understand properly, NLP is again classified into two major types. Is broadly classified into two types. One is NLU and the other one is NLG. What is this NLU, NLG? So friends, in this particular slide, we are going to understand the key concepts of NLP. Okay. So if you observe, NLP is broadly classified into two types, NLU, NLG. NLU stands for Natural Language Understanding. I repeat, Natural Language Understanding. What does NLG stands for? Natural Language Generation. So probably when you understand the abbreviation for NLU NLG, can't we understand what does NLU NLG represent? What do they mean exactly? Yes, because it is very clear that NLU helps us to understand the natural language. Okay, simple. What does NLG does? NLG is used to generate the natural language. Okay, whatever the text that we want to generate similar to natural language will be done by NLG. So the process would be like, both NLU and NLG are part of NLP. Okay, they are part of NLP. NLU, so whenever when you ask a GPT, what does it does? For example, I'm using chat GPT, friends, pre-trained, you know transformer. Okay, anyways, let us not understand about ChatGPT, but I'm using ChatGPT and I have given a prompt. What is a prompt? Prompt is nothing but an input. Assume it as input. Okay, so my input is how old are you? I'm asking question to a GPT, chat GPT, and the question is like this: how old are you? So what it has to do, what it does is initially it uses NLU component and it understands the language that whatever we give, it focuses on the comprehension, nothing but it understands the text, and based on this it is going to extract the meaning from the text that we give as input. It understands the meaning from the text or speech. Okay, and the general tasks that include are sentiment analysis, entity recognition, and question answering. That's it. Once after understanding the language, okay, the natural language, then NLG comes into the picture. What does NLG do? NLG, it is focusing on the text that it has to produce, it has to generate. So for my question, it starts answering. Yes. I assume all of us used ChatGPT, right? There is no person who is not using ChatGPT on the globe. I mean, if you are from tech background, for sure, or if you are a student, if you want to, make your task very easy, yes, all of us are habituated of using ChatGPT. But in ChatGPT, in the backend, it uses the concepts of NLP only. Why? Are we using any other data? How we are communicating? I'm using text. Yes, even NLP also works on textual data, right? So it uses NLU to understand the natural language, and it uses the NLG component to generate similar text. Okay, so it is actually focusing on the text that has to be produced like humans. Okay, and the general task would be like summarization. So upon your prompt, if you keep say how old are you, keep the answer in 2-3 lines, you'll get a summary. Probably within 2-3 lines you'll get the answer. If not, if you keep your prompt very clear, okay, so I would like to have like a story. Yes, according to your prompt, your input, chat gpt is going to answer the question. Right, so these are the two important parts of NLP, NLU and NLG, natural language understanding and natural language generation. Right, NLU helps us to understand the text, it focuses on the comprehension part, whereas NLG helps us to generate similar text like humans. Okay, so we also have speech processing. So this is actually converts speech to text and text to speech. See, when I'm talking, sometimes you'll also get the subtitles, uh, especially if you listen to any YouTube videos. So in YouTube, when you're watching a video, you have CC, where if you turn the CC on, you'll get what? What do you get? 1 minute. Good. So what do you get? You'll get subtitles. Good. So what exactly is happening? Whatever is being delivered will be converted to language. Yes. So the speech can be converted to text and the text can be converted back to speech. So even speech processing is an important concept of NLP. Okay, so we are going to understand all of these as we move forward. By understanding all the pre-processing steps, we'll also implement some kind of use cases. Okay, how we can do sentiment analysis. If not, then text summarization. This is one of the key project that is being very famous nowadays. When I give, see, when you give a PDF file, say of 100 to 200, whatever might be the pages, I'm just taking an example. if you give 100 pages PDF file to a machine, okay, so this machine is going to give an overall summary of 10 to 15 lines of this 100 pages PDF, which is of text. So text summarization, story, story generation, and all these are topics that we'll be discussing in the upcoming classes as part of this particular playlist. So friends, if you haven't subscribed to our YouTube channel, do subscribe. So you'll get all the notifications, whatever the sessions that I'm going to conduct in future as well. You'll get the notifications, right? Yes. Then there is one more topic called text mining. What is this text mining? Akhil, NLP is clear, but I'm not clear on this text mining. Can you walk me to text mining? Yes, sure. Excuse me. So, what is text mining? Text mining is it's nothing but text analytics. The analytics that we do on text. I'll go back. So, long back we discussed what means data analytics. Data analytics. What is data analytics? Can someone tell me? Because friends, I'm making the meaning for these complex words very simple. So don't get offended, right? So what is exactly data analytics? Data analytics is nothing but it's a branch of science, you know, where we extract insights, patterns, good, from data. It might be any data, yes, it might be any data, because I'm talking about all the formats of data, friends. I'm not specifically talking about one particular format. So obviously you might have understood the meaning for analytics. Analytics is nothing but to discover the insights, the underlying patterns from the data will be data analytics. In the same way, what is text analytics? Simple. Instead of all formats of data, I'm just strictly focusing on one particular format. It is unstructured data, that is text. So the process of extracting meaningful information and the patterns, insights from unstructured data, that is text. So I'm just using this word as a reference to explain text analytics, nothing but text mining. Right? So majority of the people, they get confused between text mining and NLP. There is a lot of difference. Both are not same. NLP is nothing but understanding, interpreting, and generating human-like language, because this includes both NLU, NLG. Understanding and the generating part will be done by NLP. But what does text mining do? What text mining focus on? It focus on extracting patterns and insights from text data. Is it making sense now? Because in general also you can expect a question like this. Basic questions. How do you differentiate text mining with NLP? Or how do you differentiate text mining and NLP? Text mining is just getting the patterns, the insights from text data, whereas NLP is understanding, interpreting, and generating human like language. Simple. Okay, so the goal of using text mining concepts is we transform, once in order to get these insights, the patterns, we transform the unstructured data to structured data for analysis. And the goal of NLP is to enable machines to interact with humans using natural language. Okay, so here are some of the key tasks that we do in text mining. Okay, oh, yes, like we also learn the pre-processing steps. These are mandatory in both the cases. So we'll discuss the text pre-processing steps, then the pattern recognition, topic modeling, sentiment analysis, text classification. All these would be the key tasks in know text mining. So classifying the text. Sentiment analysis is we do some kind of analysis based on the sentiment. Okay, so we'll understand, friends. No worries, we'll understand the meaning for all these words. So we'll start the pre-processing steps because this is our first day, right? So initially, we are supposed to focus on the basics well. So I'm going to start with the pre-processing steps. Okay, so what do you mean by pre-processing? Don't tell Akhil I'm not aware about pre-processing. Pre-processing is similar to cleansing. Hope you remember. We discussed crisp MLQ, right? In crisp MLQ, there are 6 phases. What is the second phase? Second phase is data preparation. What are the sub phases that we have in data preparation? Good. Under data preparation, we have EDA, that is nothing but performing exploratory data analysis on the data. On the raw data, if you perform analysis, okay, you'll get insights. Then the second part or the second phase of data preparation is data pre-processing, nothing but data cleansing. We clean the data, we transform the data, because in structured data we might have null values, outliers, feature scaling has to be done. Okay, duplicates might be present. So all these things we have discussed, right? But since the data has been changed, obviously the pre-processing steps will also change. Making sense? Here the data is structured, but in NLP, you know, in the concept of natural language processing, that data that we are using is text. You cannot expect the same methods or the topics will be used for cleaning text data as well. No, right? So the process of cleaning and transforming the raw data into meaningful I mean, if you are able to clean the data and transform the raw data, that is nothing but text pre-processing. And this clean data will be processed to the next model building part, right? So the first step under pre-processing is lower casing. What is this lower casing? Simple, you know, converting all characters to lowercase. So for example, if you have a text, okay, if there is a sentence, converting each and every character present in that particular in this particular text, if I convert each and every character to lowercase, that is nothing but lowercasing. Why we have to perform lowercasing is it will ensure uniformity, okay, in that text data, and it is also going to eliminate case sensitive difference. Why is that much important? Yes, in general, if you don't perform lower casing, you will have case sensitive issues. What is this case sensitive issues? I'll tell you. So, hello can be written in this way. This is called proper case. What is proper case? Proper case means keeping the first character of the word in uppercase and rest of the characters in lowercase. That is called proper case. What is this called? This is called lowercase, right? Keeping all the characters in the lower case is called lowercase. Anyways, this is called uppercase. I'll keep all the characters in uppercase. So I have a single word It is hello, but are they three same? Yes. A human can understand, yes, all of these three are same. Because hello is a word that we generally use to wish a person, right? If I want to wish you, hey, hi, hello, this is what we use, right? So I can clearly understand whatever might be out of these three words. I can understand that all of three are same. But a machine, a computer, can it understand? The first question. The main reason is, if you see here, hello is not written in the same case. In first case, it is written in proper case. In the second one, it is written in lower case. In the third one, it is written in upper case. So, to bring uniformity, okay, and moreover, to treat all of them as same words or same tokens, we perform lower casing so that whatever might be the word will be converted to hello. Even if you keep it in uppercase, lowercase, or proper case, swap case, any different types of cases, friends. Okay, when you use lowercase, and the function that we use generally is lower. I already discussed this particular function as part of my Python sessions, right? The same function. Excuse me. So this is also going to reduce the dimensionality and it improves consistency. Yes. I had a small example to explain lowercasing. So I took the text like this. Hello world, exclamatory, NLP is amazing, full stop. This is my text. Akhil, how can you tell that this is your text? Because you are using a variable text, right? No. Observe, I'm keeping all of them in string. So obviously, what does a string means? String is nothing but group of characters or sequence of characters. Friends, I have to go back and probably you have to recollect the concepts of Python. In Python, we discussed str data type, right? So what does str data type mean? Collection of characters, a group of characters. So you see a group of characters? Yes. And this group of characters, what am I doing? I have stored in text and I'm converting this group of characters, this string to lowercase by using lower function. Okay, so text.lower function will convert this string to lowercase and that gets stored in lowercase underscore text. And when I print, so this is my output. I just took an example so that all the pre-processing steps can be understood very clearly. Anyhow, we'll perform them, but what makes the difference? Hello is in uppercase, proper case, but here the hello is in lowercase. Same as word, NLP, then amazing. Making sense? Right. So this is the first step. Now, as part of pre-processing, we understood lower casing. Let us continue. Let us also discuss a few more, which are very easy for us. Okay. The pre-processing steps that we are learning as part of NLP, on text data will be very easy, friends, because majority of them will be using our real time as well. The second one is spelling correction. This is a process of identifying and correcting misspelled words. So within your text, okay. So not every time each and every word will be spelled correctly, right? So you see here, I'm going to the store, but if you see going is misspelled, it is not spelled correctly. So when you use spelling correction, what happens is it is going to identify the misspelled words and that gets rectified. What is the issue in this second string? Sitting. The spelling for sitting is not correct, so identified and rectified. It got corrected. Then beautiful, BA. So this helps us to do error detection, Okay, once after identifying the potential misspelling words in the text, it is also correcting the misspelled words, right? So this is also a mandatory step that we generally do as part of pre-processing under NLP. Then the important and mandatory pre-processing step is tokenization. What is this tokenization? It's very simple. Tokenization is a process of splitting text into smaller units called tokens. So if you have a text, the text that you have will be split into some units, small units, they are called tokens. That is nothing but tokenization. Okay, so what are tokens? They can be words, they can be sentences, or they can be subwords also, depending on the granularity that you are required. So what type of tokenization you are going to apply, accordingly you'll have the output. Okay, so friends, under tokenization we have multiple types. We are going to look after all the types of tokenization. That's okay. Okay, so this is a mandatory step that we have to perform on text data. So what exactly happens is, if I take this is my text, this is sample text, and if I tokenization, what happens? So obviously it starts splitting the text. This is a sample text. So each and every word is a token here in this example. Okay, but what kind of tokenization they use, we'll discuss. Then what is corpus? Corpus is nothing but the large unstructured, collection of text is nothing but corpus. So whenever you will be using text data, you'll have some paragraphs in this text data. Yes, in simple, the paragraphs that we have in the text is called corpus. It's called corpus. Then within these paragraphs, you'll have sentences. Yes, and these sentences are called documents. So some technical terminologies I'm trying to explain. Focus. The paragraphs are called corpus, the large unstructured collection of text, and the sentences that we have in these corpus are called documents. When I take this sentence and if I apply the tokenization, I'll get tokens. This is what happens, right? Now let us go and understand what are the types of tokenization that are available. So you see, upon the requirement, okay. So upon the requirement, so you are going to perform different types of tokenization. The first tokenization is word tokenization, very widely used and easily explained. Word tokenization is nothing but splitting the text into individual words. So whatever the example that we have understood previously, this is a sample text. On this is a sample text, we have applied word tokenization only, friends. What does this word tokenization does is, you know, it splits the data, it splits the text into individual words. So when we generally use this word tokenization, whenever you going with sentiment analysis, text classification, or and machine translation, different types of cases, we generally use word tokenization. Okay, and the delimiter that we generally use is spaces and punctuation, white space. So within your text you'll have white space. Yes. Also you'll have punctuation marks. Yeah. So the words get split based on spaces and punctuation mark. Here is the input followed by output. I'll take an input. See, I love NLP full stop. It is amazing exclamatory. So this is my text data. What am I doing? Let me go and use word tokenization. So what should be the output? So each and every word, wherever there is white space, it has to, you know, split the text. I love NLP, but punctuation is also considered as a token under word tokenization. Then followed by it is amazing. Are we done? No. We also have exclamatory. Okay, so you see, this is how word tokenization works. But the general challenges with word tokenization is it does not handle the punctuation properly. Like examples. See, instead of keeping the entire abbreviation for NLP, I would like to keep NLP full stop. So in some cases, what we do instead of keeping the entire acronym, you know, expanding the abbreviation, what we do, we mention the word using from full stop, so that will be written as NLP. That will be split into NLP only. And moreover, if you see don't, it also it does not deal the contractions properly, friends. See, if you have a word like don't, it splits into do n colon t or don't as it is. This is not rightly done, right? So because of this, we have some challenges, right? So let us go and understand the next level of tokenization. It is sentence tokenization. What is sentence tokenization? Simple. Word tokenization is going to split the text into words. So sentence tokenization will go and split the data into sentences. So whatever the corpus that you have will be split into individual sentences. Okay, and what is a delimiter? The delimiter that generally used by sentence tokenization is punctuation marks. Okay, see, because when do you say that a sentence is completed? When it ends with period, nothing but full stop, exclamatory mark, question mark. So these are some generally used punctuation marks to end a sentence. So wherever it identifies these sentences, I mean these punctuation marks, so it starts splitting. I'll take the same example. I love NLP. It is amazing. So I love NLP will be one token. It is amazing will be the other token. So that makes the difference. Observe the difference. Word tokenization, sentence tokenization. But what kind of challenges do you face in sentence tokenization? See here, Doctor, Akhil. Anyhow, I'm not a doctor, friends. I'll just take an example. If I have Doctor Akhil in my text, in my corpus, when I use sentence tokenization, obviously till doctor, since it is going to you know see that full stop, immediately it splits the sentence here. Yes. If not, U dot space S dot A. Okay. So instead of keeping United States of America, I would like to keep it like this. In my text, I have like this. When I use sentence tokenization, since I have full stop, U will be part of one text. I mean, it will make one token till U, the other token you'll have S, and the third one you'll have A. So it fails in these three cases. So these are the challenges that we generally observe with respect to sentence tokenization. Right. Then let us go understand the next type of tokenization. It is tweet tokenizer. What is this tweet tokenizer? So from here onwards, all the different types of tokenization that you are going to use will be used upon the data specifically. Okay. So tweet tokenizer is generally designed for Twitter data friends. Okay, so you'll have, all of you are aware of Twitter, right? Recently, not recently, it's been some months. This Twitter got renamed as X by Elon Musk because he owns it. right? So in order to handle Twitter data, X data, the tweets, we also have tweet tokenizer. So if this is your tweet, hey, @user, comma, check out this hashtag NLP tutorial, then emoji. Okay, so this input, if I on this input, if I use tweet tokenizer, this will be my output. Similar to vote tokenizer, but explicitly it is designed for Twitter data. Right? I'll not talk much about tweet tokenizer. Let us go and use. Let us go and understand MWET tokenizer. What does this MWE means? Multi-word expression. Okay. What does this multi-word expression tokenizer does? A multi-word expression tokenizer, you know, it is going to convert. It is going to convert the text into multi-word expressions as single tokens. Example like New York is considered as one of the token. Okay, so it is generally used in the case of NER. What is this NER? We'll understand. Named entity recognition. So we'll talk about this NER probably in the next session because we are running out of time. Okay, but we'll discuss. If you see here, what am I trying to do? I take a text. I'm taking a text. I live in New York, and I'm using multi-word expression tokenizer, MWE tokenizer. But in general, if you use word tokenizer, the output will be like I live in New York full stop. So New York is a city. It should not make into two tokens. It should be only under one token. Right? So when you use word tokenizer, you'll not get the right output. Instead of that, multi-word tokenizer should be used. Okay, so this actually groups multi-word expressions into single tokens like here. New York will be part of only one token. It does not split. Okay, so it is generally used in NER concept. I'll talk about NER probably in the next session. Okay, right. We also have few more tokenizers, the types. Regex. So friends, we also have regular expressions tokenizer. Okay, so regular expressions is a part. It's a library that we have designed especially for text data. Okay, and this particular tokenizer uses the regular expressions to define the token boundaries. What should be part of each and every token will be decided by regular expressions. So in order to in order to use regex tokenizer, you should be familiar with regex patterns. See, here I'm taking an input email space me space at the email, a random email I have to. Okay, when I use a regex pattern, see what does my pattern says \w plus vertical pipe \s. What is this? Can't even understand, right? So we should be familiar with regex patterns. This actually means match words or non-white space characters. Okay, it will match only words or if there is any non-white space characters. This is white space, this is white space, white space. Apart from white space, anything which is non-white space characters, only that should match is what the pattern says. And accordingly, you have the output. See, email me at the mail ID. And finally, exclamatory mark. Okay, it's very complex because of the patterns. You're supposed to be clear on the patterns, friends. If you're not that much clear on the patterns, you may not understand the regex tokenizer. Okay, this regex tokenizer is especially built for it uses the concept of regular expressions to build the tokens. Okay, excuse me. Then we have white space tokenizer. The name itself, we can understand within the name, we can understand that wherever there is a white space, so obviously that is going to be the boundary mark for the token, right? So it is a simple tokenizer that splits the text based on white space characters. If you see in my input, I have I space love space NLP full stop. When I use white space character, wherever there is white space, only at that particular white space it starts, splitting the text and use the tokens I love NLP full stop. And you can also, ask me, Akhil, is this similar to word tokenizer? No, because when you use word tokenizer, obviously the output will be same, but it also gives a separate token for the full stop. But white space, no. Until unless it sees white space, only then it gives us, you know, the tokens. So that is the first challenge. Punctuation handling. We cannot handle the punctuations because no one you keep the punctuation mark by adding a space. See, if I want to keep I am Akhil, okay, if this is my sentence, I'll use punctuation full stop, immediately after Akhil, or will I provide space and then I'll put full stop? This is wrong, right? So immediately I'll use full stop. This is correct. So that is the reason it cannot handle the punctuations properly. The white space tokenizer, right? So for each and every tokenizer, there are some challenges. That's what. Accordingly, we have to use. Upon the requirement, we are supposed to use the tokenization. And still we have tree bank tokenization, word puncture tokenization. Okay, so tree bank tokenization is used based on some rules. Okay, it's a rule-based tokenizer that follows pen tree bank tokenization. So there are some rules upfront you have to define. Okay, accordingly, this tree bank tokenization will work. Upfront, you are supposed to come up with the rules that you are going to use. Okay, and these can be customized. Yes. So here is an example. You see, I'm providing my contractions. See, if you see any words like don't, it has to be split like this only. Okay, and if you have any word happening with if they are connected with hyphen, it should not be splitted. It should be given as it is. If you find any word with a punctuation mark, it should split both the words, the punctuation mark as a token and the word. And if you have any again possessives, again they have to handle properly. So accordingly, whenever you are deriving your rules properly, the output will be as is. But if I use any other tokenizer instead of tree bank for the same text, I'll get the output different. The different output will be there, right? Then we also have word punct tokenizer. So word punct, which is nothing but it is going to split the text into words and punctuation marks separately, right? So this is again similar to word tokenizer. Yes, because even word tokenizer also does the same. So if you see I love NLP is my input text, what it is going to give, I separate as a token love, then NLP, and finally a punctuation mark, exclamatory. So this is how there are different types of tokenization, and we understood all the possible types of tokenization. And okay, I'll not introduce a new topic today because it's already, we are done with the time. We are running out of it. Probably now I'll take your questions. So friends, it's a good start that we had today with respect to natural language processing. And if you feel the same, before you leave, hit on the like button and do share across your connections, ask them to join the sessions and learn these important topics as part of AI. Okay, so all of us have a mindset of learning AI, right? Every one of us have, I should learn AI is what we feel, but someday you have to start it. So this is where you are supposed to start, and moreover, we are going to deal all the topics from basics, right? Thank you for your feedback, my friend. So before you leave, hit on the like button, and also if you have any kind of questions, keep it over the comments. We'll respond immediately. And moreover, we'll be sharing the feedback link. Provide your valuable feedback, your suggestions. We'll implement in the future sessions as well. Right. So that's all for the day. Again, we'll meet in the next session. Until then, take care. Have a great day. Signing off.